I just wanted to make a quick video real quick on how to tell the difference in naming and in writing a formula for an ionic compound. And with your ionic compounds, they are named differently if you have a representative element, which are all in red on my periodic table here, or if you have a transition metal, which are in the gray. With your representative elements, they always have the same charges. So group 1 has a +1 charge, group 2 is always +2, group number 13 is +3, then you have plus or minus 4, -3, -2, and -1. Because they always have the same charges, you don't need to worry about using those Roman numerals to tell the charge of the metal. However, with your transition metals, and for my class we also include tin and lead in those transition metals, they're going to get Roman numerals. The Roman numerals tell you the charge of the metal. They do not tell you how many there actually are. You get how many there are from the number of, not from the number of, but from the oxidation numbers when you swap and drop. So I've got a couple practice problems similar to what you would have in your homework packet, and they're mixed up whether they are a representative element or it's a transition metal. So I'm going to do the name to the compound first. When you have the name of the element, what you're going to need to do is you need to look at your periodic table. And when you look at your periodic table, you want to know, is it that representative element or is it a transition metal? So the first one that I have is gallium. Gallium is here, it's a representative element. It always has a +3 charge. So we have gallium +3. Sulfide, IDE, is sulfur. Sulfur has a -2 charge. So in order to swap and drop, remember the plus and the minus disappear. The 3 comes over here, the 2 comes over here, so your formula for this one is Ga2S3. For lithium carbonate, you're going to do the same thing. Find lithium on the periodic table. Lithium lives in group number 1. So with lithium living in group number 1, it always has a +1 charge. Carbonate, ATE, is a polyatomic ion. So carbonate is CO3, and then that is a -2 charge. So again, you're going to swap and drop, so the 2 is going to come over here. So Li2, and then CO3. With that carbonate, you only have one of them. It honestly doesn't matter to me if you put it in parentheses or not. So this answer, oops, I forgot my 2, would be the same thing. For cobalt-2 hydroxide, this 2 right here, it's the oxidation number of cobalt. So this is telling me that cobalt has a +2 charge. So this right here means +2. Hydroxide is a polyatomic ion. Hydroxide is OH-1. So when I go to swap and drop here, you end up with COOH2. Now the last one that I have on my page, I have scandium 3 chloride. Again, this 3 right here tells me that scandium has a +3 charge. So we have Sc +3. We have chloride, which is chlorine, with a -1. So we're going to swap and drop there. So you end up with ScCl3. Now if you have the formula, and I want you to write the name, look at the first element. When you look at the first element, find it on your periodic table and figure out, is it representative or not? If it's a transition metal, it's going to get Roman numerals. And then we also include, don't forget, tin and lead in that. I don't have tin or lead on my example problems, but if it did, we would give those Roman numerals as well. So if we have CaCl2, calcium lives in group number 2 on the periodic table. So it's not going to get Roman numerals. So all we do is we name our cation, calcium, and then Cl is chlorine. Chlorine becomes chloride. So this one's just called calcium chloride. Now on the next one here, I have Fe2O3. For my Fe2O3, Fe is a transition metal. So because iron is a transition metal, we're going to use Roman numerals to tell the charge of your iron that they use to swap and drop. O is oxygen, so that changes to oxide. So now there's a couple options here just to kind of refresh what we talked about in class. You can either go about it this way, that you have 2 irons, you have 3 oxygens, Every oxygen always has a charge of -2, so that gives me a total charge of -6. This side has to be +6 to equal 0. So in order to get the charge, we're going to divvy that up between the two irons. So each iron has to be +3. So you have iron 3 oxide. Now just remember, you do have that other option of reverse swapping and dropping, where you bring your +3 over here and that 2 comes back over here. But make sure you check the charge of oxygen on the periodic table just in case it doesn't work. Then if it doesn't work, you'll have to do it the long way. For the next one, I have barium, and then I have phosphate. Barium on the periodic table is a transition metal, or it's not a transition metal, sorry. Barium is not a transition metal. It lives in group number 2, so that means that it doesn't get Roman numerals. So you just have barium, and then PO4 is phosphate. So we have barium phosphate for that one. Now the last one on my page, I have WS3. W is tungsten. Tungsten is a transition metal. So it's going to get Roman numerals to tell the charge of tungsten. And then S is sulfur, so that becomes sulfide. So just to try the reverse swap and drop, there's 1 tungsten, it comes over here to be -1. 3 comes over here to be +3. Now on this one, sulfur does not have a -1 charge. Its charge is -2. So because sulfur has a -2 charge, we have to either reverse swap and, or sorry, you cannot reverse swap and drop. Either write it out the long way or readjust this. So sulfur is actually -2. So I have 1 tungsten, I have 3 sulfurs. Every sulfur has a -2 charge. So that gives me a total charge of -6. If this side is -6, that means my tungsten is +6. So we have tungsten 6 sulfide for that one.